Today we're going to graph exponential functions in the form a times b at b to raised to the x power. We're not going to have any shifting left, right, or up or down today. So we're just going to deal with an a value. So remember when we graphed cube root and square root functions, we had a table. And we're going to do the same thing with exponential functions. We're going to have a table. So an XY table. And the X values that you're always going to use are -2, -1, 0, 1, 2. Now, the Y values are the values that students usually have an issue with. So what we will always have is we will always have 0, 1. Okay, that's what we're always going to start with. Then we're going to look at our B value. So let's write that down over here. Step 1, 0, 1 is in the table. And then step 2, we're going to multiply by our B value. Multiply by B value. So I'm going to take my 1 and multiply by 3 because it's my B value, and I get 3. And then take 3 and multiply it by 3, and I get 9. And they say, well, what about the other two? When x is -2 and x is equals -1, what goes there? Well, we're going to go backwards, so then we have to divide by 3. So we get 1/3 and 1/9. You could also think of it as the reciprocal of these two y values. Remember, reciprocal is when you flip the fraction, so 3 over 1, you flip that and it's 1/3. Now, just like with cube root functions, we're going to have a third row, and we're going to multiply all the y values by our a value, which is 2. So 1/9 times 2 is 2/9. 1/3 times 2 is 2/3. 1 times 2 is 2. 3 times 2 is 6. And 9 times 2 is 18. And we're going to cross off that middle row. And we're going to plot these points. -2, 2/9. So just get as close to 0 as you can. Get right about there. -1, 2/3. All right, we're getting closer to 1. 0, 2. 1, 6. And for 2, 18, just use your best guess. It's going to go like that. So this is exponential growth because our B value is positive, and if you look at the graph, it's going up and to the right. The domain. The domain of all exponential functions is going to be -infinity, infinity. The range is where things get a little bit complicated. Our y values will never equal 0. So remember the other day when we were talking about the Alice in Wonderland problem, and she kept shrinking, her height kept going down by half, she would never be 0 inches. She would get closer and closer to 0, but never actually be 0 inches. So the range is going to be 0, infinity. We also kind of introduced the word asymptote. An asymptote is the value that the function gets close to or approaches, but never equals. So in this case, that is y equals 0. We never get our y values to 0, but we get really, really close. So now the end behavior as x approaches negative infinity. So look at my green line here. As my x values get closer and closer to negative infinity, my green line or my y values get closer and closer to that asymptote, which is 0. So y approaches 0. You'll notice something. Our range, our asymptote, and our end behavior all match. Okay. And then we have to worry about the right side. As x approaches positive infinity, y approaches positive infinity. The y values are going up. Okay. So let's look at the next one. We'll start with our table. xy and our x, -2, -1, 0, 1, 2. We'll start with 0, 1. Our growth rate, or the b value, is 1/2. So now we're going to multiply it by 1/2. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. And then going backwards, 1 divided by 1/2 is 2. 2 divided by 1/2 is 4. Or remember, you can flip those values. And then we'll make our last row. And we're going to multiply everything by 8 because that is our a value. 4 times 8 is 32. 2 times 8 is 16. 1 times 8 is 8. 1/2 times 8 is 4. And 1/4 times 8 is 2. So we'll graph those. -2, 32. So it's going to be way up here. -1, 16, so way up here. Oh, let me cross that off. 0, 8. 1, 4. And 2, 2. So this graph starts large and then it gets smaller and smaller. So this is exponential decay. And again, you should recognize that because your b value, that growth rate, is less than 1. Domain, -infinity, infinity. Our range, the y values get closer and closer to 0, but they go all the way, the y values go all the way to infinity. The asymptote is y equals 0. Now for the end behavior, it's going to be the opposite of what we had up here. Look at up here, the right side of the graph is going up. Down here, it's the left side that's going up. The left side of my graph has the arrow pointing up. So as x approaches negative infinity, y approaches positive infinity. And as x approaches infinity, y approaches 0. And you can see the range, asymptote, and the end behavior all have that 0 for y. All right, now let's look at the next page. And you'll notice that we have a negative sign here. So that's going to change how our graph will look a little bit. So x, and then y, and -2, -1, 0, 1, 2. We start with 0, 1, and our growth rate is 4, so 1 times 4 is 4. 4 times 4 is 16, and then going backwards, we'll get 1/4, 1/4, and then we'll get 1/16. Now for the third row, we're going to multiply all the y values by negative 0.5. So 1/16 times negative 0.5, well, 0.5 is like 1/2. 0.5 equals 1/2. So you could think of it as 1/16 times negative 1/2. That's going to give us negative 1/32. 1/4 times negative 1/2 is going to be negative 1/8. 1 times negative 1/2 is going to be negative 1/2. 4 times negative 1/2 is going to be negative 2. And then 16 times negative 1/2 is going to be negative 8. Because we want to keep it with fractions and not convert everything to decimals. So now let's plot this. Cross off the middle row. Negative 2 comma negative 1/32. So really close to 0. Negative 1 comma negative 1/8. Still close to 0. 0 comma negative 1/2. 1 comma negative 2. And 2 comma negative 8. So our graph looks like this. Now, you may think, oh, this is exponential growth because our b value is 4 and that's bigger than 1. But look at the graph. Your y values aren't growing. If this is exponential growth, your y values would be getting larger and larger, getting closer to positive infinity. But instead, the y values are getting smaller and smaller, going towards negative infinity. So this is actually neither. It's not growth and it's not decay. Domain, negative infinity comma infinity. Our range, well, the y values go all the way down to negative infinity, and they approach 0. If you look at the left side, the graph gets closer and closer to 0. Asymptote, y equals 0. And behavior, as x approaches negative infinity, the y values are getting closer and closer to 0. And as x approaches positive infinity, y approaches negative infinity. The right side has the arrow going down. So that's why the right side is going towards negative infinity. So now we're going to create tables for each of these equations. So we're going to do negative 2, negative 1, 0, 1, 2. 0, if you were to plug in 0 for this, you would get 1. And then we're going to multiply by 2 each time. And you may say, well, what about the negative? We'll deal with the negative in a minute. So 1 times 2 is 2. 2 times 2 is 4. And then going backwards, 1/2 and 1/4. And just to double check, 1/4 times 2 is 1/2. 1/2 times 2 is 1. 1 times 2 is 2. And 2 times 2 is 4. Now, this negative sign is not in parentheses. So that means all of my y values need to be negative because it's not in parentheses. It's like having an invisible 1 or an invisible negative 1 as your a value. Letter B, negative 2, negative 1, 0, 1, 2. Now, if I plug in 0 for this, up here, we made 3 rows to help us graph it. Down here, we're taking out that middle row. And you can see up here that the point 0 comma a is on all of our graphs. Our a value is 8 right here. We had 0 comma 8. Here we had a value 2. We had 0 comma 2. So then you might say, well, why didn't we just do that in the first place? I found that it is easier to have that middle row first and then build that second one, that third row, and graph that when you're asked to graph. But when we're just asked to make a table, you know that we can always just plug in our values. So it's going to be 0, 3. And then we're going to be multiplying by 4 each time. Times 4. Times 4. Times 4. Times 4. So 3 times 4 is 12. 12 times 4 is 48. And then going backwards, 3 divided by 4, or 3 over 4. And 3 over 16. Most students struggle going backwards, and that's because when we did the graph, we did the reciprocal of these two numbers, the 12 and 48. Well, that's not going to be 1 over 12. Whoops. Okay, then we have this one. We plug in 0 for x, we'll have 0, 10. But then our growth rate is 1/2. So we are multiplying by 1/2 each time. Times 1/2 times 1/2. 10 times 1/2 is 5. 5 times 1/2 is 5 over 2. Going backwards, 10 divided by 1/2 is 20. And then before that, we get 40. And again, double check. 40 times 1/2, that gives you 20. 20 times 1/2 gives you 10. 10 times 1/2 gives you 5. 5 times 1/2 gives you 5 over 2. So it's something that you can do quickly just to make sure you have the correct values. So down here, we're going to write the rule or the equation for the functions, and we're going to use fractions and not decimals. So we need our a and our b value. B is our growth rate, but a is our starting value, or the y-intercept. So you see from the first table, we don't have x equals 0 anywhere. So our table needs to be expanded a bit. And if we look at the y values, what's happening here is we're dividing by 4, or multiplying by 1/4. Times 1/4, times 1/4, times 1/4. Because you get 192 times 1/4 gives you 48. 48 times 1/4 gives you 12. 12 times 1/4 gives you 3. 3 times 1/4 gives you 3 over 4. And 3 over 4 times 1/4 gives you 3 over 16. So the b value is 1/4 because that's what we multiplied by. And the a value is our y-intercept, or 3 over 16. So that would make the equation y equals 3 over 16 times 1/4 to the x power. We're going to skip letter B. Now C, okay, we have our y-intercept already right here. Okay. When x is 0, y is 1/2, so that means our a value is 1/2. So then we got to see what is happening with the y values. And if it's hard to see from 1/8 to 1/2 what is happening, you can look at any consecutive y values. For you, it might be easier to look at 2 and 8. Oh, 2 times what gives you 8? That's easy, that's 4. Okay, so that's our growth rate. 8 times 4 is 32. 1/2 times 4 is 2. 1/8 times 4 is 2. So our b value is 4. Sorry, 1/8 times 4 is 1/2. That's what I meant. Our b value is 4. So y equals 4 times 1/2 to the x power. So this is a good introduction to graphing exponential equations and finding their equations from tables. We'll do a little bit more of this, and we'll start shifting them too. So thank you for watching. Make sure to hit that like button and subscribe.